3.1 Translational Kinetic Energy. This empty shopping cart is moving, which means it has translational kinetic energy. According to Ke equals 1/2 mv squared, kinetic energy depends on both the mass of the object and its velocity. Since the empty car has a small mass, it doesn't take much energy to get it moving quickly. Now I'm inside the shopping cart, so the mass of the system increases a lot. Because mass is part of the kinetic energy equation, the cart now requires much more energy to move. Even though the heavier cart moves slower, the system can still have a large amount of kinetic energy because the mass is increased. This demonstrates that translational kinetic energy depends on both velocity and mass. Changing either variable changes the total kinetic energy of the system.
When Zohaib lightly hits a tennis ball, the ball moves at a slower velocity. Because the ball is moving slowly, it has less translational kinetic energy. In the equation 1/2 mv squared, velocity is squared, so the speed has a major effect on kinetic energy. That's why I have enough time to react and easily dodge the ball. Now Zohaib hits the tennis ball much harder, increasing the ball's velocity. Since velocity is squared in the kinetic energy equation, the kinetic energy increases by a large amount. The ball reaches me much faster, giving me less time to react, so it's harder to avoid.
Right now the car is moving at a low velocity, so it has smaller amount of translational kinetic energy. Based on Ke equals 1/2 mv squared, kinetic energy depends on both mass and velocity. Since the mass of the car stays the same, velocity is the main variable changing in this example. Now the car is moving much faster because the velocity is squared in the equation. Even a moderate increase in speed causes a large increase in kinetic energy. This means faster moving car carries more energy than before. This demonstrates that translation kinetic energy increases rapidly as velocity increases. Speed has a major effect on the energy of a moving object.
3.2 Work.
Steroid's gonna come in handy.
This foolish guy has been pushing against a wall for the last 5 minutes thinking he's doing something productive. In everyday language, it looks like Bilal is doing a lot of work because he's exhausted. But in physics terms, he actually did zero work. Work equals force times distance. Work only occurs when a force causes displacement. The wall never moves, so the displacement is zero. And if displacement is zero, then the total work done on the wall is also zero. So Bilal wasted all his energy fighting a wall that didn't even care. This demonstrates that in physics, no matter how hard you push, if nothing moves, no work is done.
At first, I thought holding this heavy object would be easy, but now my arms are completely cooked. The funny part is that in physics terms, I'm basically suffering for no reason. Work equals force times distance. Work only happens when a force causes displacement. I'm applying an upward force to hold the object, but the object isn't actually moving upward. That means the displacement is zero, so the total mechanical work done on the object is zero. So even though my muscles are dying right now, according to physics, I technically did no work.
3.3 Potential Energy.
Alright, big low. This is height of one below, and we're gonna drop the ball from here.
Here I'm releasing the ball from a lower height on the staircase. The ball has gravitational potential energy because it's positioned above the ground. According to Ug equals mgh, at the lower height, the ball has smaller amount of gravitational potential energy. As the ball falls, the stored energy begins converting into kinetic energy.
Alright, big low. I'm up here right now, and this is height of 3 belows. So we're gonna drop it. 1, 2, 3.
Now I'm releasing the tennis ball from a greater height. Since height is part of the equation, the ball now has more gravitational potential energy. This means more stored energy can be converted into kinetic energy as the ball falls, so the ball speeds up more before reaching the ground. This demonstrates the gravitational potential energy depends on an object's mass, gravity, and especially its height above the ground.
Yeah, you're not getting it back, boy.
Oh, ball back.
Come here!
You squeeze your back.
Alright, fine, you can have me.
Azan climbed higher up the stairs before dropping my tennis ball. That increased the ball's gravitational potential energy because the height of the ball above the ground increased. In this equation, Ug equals mgh. Height directly affects the amount of stored gravitational energy. So when Azan dropped the ball from higher up, more potential energy was converted into kinetic energy as the ball fell. The higher the ball started, the more energy it had.
3.4 Conservation of energy.
As I swing higher into the air, my Keting energy decreases while my gravitational potential energy increases. According to UG equals mgh, at the highest point of the swing, my speed is very small, so most of the energy is stored as gravitational potential energy. As I move downwards, that stored potential energy converts back into kinetic energy. According to Ke equals 1/2 mv squared, at the bottom of the swing, my speed is greatest, so kinetic energy is at its maximum. This demonstrates conservation of mechanical energy because energy continuously changes forms between kinetic and gravitational potential energy, while the total amount of energy remains approximately the constant.
3.5 Power.
Bro, number one for what, bro? You're so trash. Beat me 1v1, right? I'm not even lying, bro. Like, you're so trash. Like, walking a game.
Alright, bet, watch this, let's go.
Alright, bet. Let me see what you got.
Alright, return this, boy.
Any day now. Damn, bro. You're good.
Yeah, that's what I thought, boy. After hearing all that trash talk, I increased the power of my serve. According to P equals W over T, power measures how quickly work is done or energy is transferred. On the second serve, I transferred much more energy into the tennis ball in a short amount of time. That increased the ball's velocity significantly, making it much harder for Azan to react and return the shot. This demonstrates that increasing power allows more energy to be transferred rapidly, producing a faster and more difficult serve.
I'm Bilal, and I taught Big Low Physics.
Go.
4 seconds. ZT in the building. Best tennis player in the clear, bro. Let's see how fast I am.
4 seconds. Zohaib and I both climbed the same flight of stairs in the same amount of time, but since I have greater mass, I gain more gravitational potential energy while reaching the top. Because my mass is larger, the total energy transferred to my body is greater. Power measures how quickly energy is transferred or work is done. P equals work divided by time. Since we took the same amount of time, but I transferred more energy by lifting more mass upwards, I produce more power while climbing the stairs.
Oh, long day at work. Don't forget your groceries.
Thank you.
Got you, man.
So easy, man.
With only one grocery bag, Bilal is carrying a relatively small amount of mass. That means less work is needed to move the groceries upward against gravity. Now Bilal is carrying many grocery bags, greatly increasing the total mass of the system. Because the mass increased, more gravitational potential energy must be gained while climbing the stairs. This also increases the amount of work Bilal must do. P equals W over T. Power measures how quickly work is done. Since Bilal is doing more work by lifting mass more upward, he must produce more power to climb the stairs. That's why he moves much slower while carrying all the grocery bags. Bilal thought taking all the groceries in one trip was efficient. Physics disagreed. Do you want to see an example of work? Wait. Why are you actually tough? What the? Bro, you're gonna throw up.
I'm gonna see you. I'm gonna let you die, bro. Fans. Michael Kobe.
I'm sorry. I can't, bro. You're just. Yeah, I can't.